in this problem, we're told you drop a 12-gram ball from a height of 1.5 meters and it only bounces back to a height of 0.75 meters. What was the total impulse on the ball when it hit the floor? So if we go ahead and draw what's going on here, so imagine this is where we're dropping the ball from. We know this is 1.5 meters. The ball is going to fall down, hit the ground, and then it's going to travel back up 0.75 meters. And we know the mass of the ball is 12 grams, which is essentially 0.012 kilograms. All we did was divide it by 1,000. So this right here is going to be our drawing. And so what are we trying to find here? So essentially what we're trying to find is the impulse, right? And we can denote that by J. And so J is equal to the change in momentum. So we need to find the change in momentum. We know that momentum is equal to m times v. And so if we're finding the change in it, and we're assuming a constant mass, which in this case we have one, it's just going to be m times v final minus v initial, or however you want to write it. So essentially what we need to do is find the final velocity, which is just going to be the velocity right after the impact. And then the initial velocity is right before it impacts. So we need to find both of those. So let's go ahead and start with finding one of the velocities. And so how are we going to do that? So you need to know two formulas, the formulas for kinetic and potential energy. So kinetic energy is 1/2 mv squared, potential energy is mgh. So let's go ahead and start with right before it's about to land. So we know it's going to fall for 1.5 meters, and then it's going to have some velocity right before it lands, and that's what we're trying to find. And so if we use, we're trying to solve, or if we take the potential energy and kinetic energy and set it equal to the potential energy and kinetic energy right before it lands, you're going to get, if you go ahead and do that, you're going to get 1/2 mv squared is equal to mgh, right? And the reason this is because one of the h's, or one of the potential energies on one of the sides, is going to cancel, and then the kinetic energy on this side, or on this side, right? So potential energy on this side cancels, so that goes away on this side, but the kinetic energy on this side is going to go away because we're starting from rest. So essentially you're going to get 1/2 mv squared equals mgh, right? If you go ahead and solve for v, you're going to get v equals the square root of 2gh, right? The masses would cancel, and then you multiply both sides by 2 and square root. So if you go ahead and do this, we can solve 2 times 9.8 times the height. And so the height, essentially, if you go ahead and do this, so plug it in your calculator, 2 times 9.8, right? And then it's the height, I forgot to write that, 1.5, right? Because it's falling from a height of 1.5 meters. Right, that's the height on this side. The height was 0 on this side, so v is going to be equal to 5.422 meters per second. I'm just going to say 5.42 meters per second. So that's going to be one of our velocities. Right, so that's one velocity. And so now this is the initial velocity, by the way. And now we need to find the final velocity. And so we're going to be using the same idea, except for it's going to be rising up 0.75 meters instead of the other way around. So essentially, we would solve this again, but except for the height is going to be 0.75. So just keep that in mind. The only thing changing is the height in this thing because it's going to go up 0.75. So velocity is going to be equal to 2, or the square root of 2gh, but v is going to be equal to 2 times 9.8 times the height, which is 0.75. So go ahead and plug this in your calculator. 2 times 9.8 times 0.75. If you go ahead and do that, v is going to be equal to 3.83 meters per second. So keep in mind this was the initial, and then this was the final, right? So we're saying initial is right before it lands, final is after it lands. So now we can just plug it in, right? So change in p is going to be equal to the mass, which we said was 0.012, multiplied by the final, which is 3.83, and then you're going to be minus. And so keep in mind, we didn't label it here because I just said the magnitude here, but keep in mind that this is going to be negative when we plug it in, because when we actually take into account the formula, we have to take into account direction. So this one's going down while this velocity is going up. So what this means is this is negative. So when we plug it in the equation, it's really going to be adding it, because we're doing minus 5.42, because this one's going down, so it's negative, and then upwards would be positive. So 3.83 minus 5.42, so really plus. So you're going to have 0.012, and then multiply that by 3.83 plus 5.42. So if you go ahead and do that, you're going to get that it equals 0.111 I'm just going to round to the 11. So 0.11, and then it's going to be kilogram meters per second. So kilogram meters per second, 0.11. So, right, because we're using meters per second in kilograms, and we're multiplying them. So 0.11 kilogram meters per second. So this right here is going to be your answer, and hopefully you found this useful.